Okay, so solve the differential equation here. dy dx equals 1 plus y squared. So we're going to separate the variables, all right? There's no terms here next to dy dx. Okay, so it's just 1 here, yeah? And this 1 plus y squared, we sort of keep it as one package there, so to speak, but it's on top, isn't it? So when you take it over, you're going to divide. So it'll be 1 over 1 plus y squared, and the integral of that then, with respect to y. And there's no x terms there, so when you take that dx over, it's just going to become 1 times dx. Okay, so now we've got to integrate this, right? Now, it's different to the previous ones, yeah? It's not going to be ln, because it's not linear on the bottom. Okay, we've got y squared. So how do we go about integrating this? Now, this is where we need to turn to our formula booklet, okay? Because we've got some results on there on page 7, and this result in particular, I want you to look at on page 7 is when you have to integrate a squared, 1 over a squared plus x squared with respect to x, you have the result 1 over a tan to the minus 1 of x over a. Okay, so that's on page 7 in the formula booklet. Okay, now if you compare that result, okay, with what we've got here, and obviously in the formula booklet, you know, the little a there is just a constant, all right? The result is perfect, isn't it, for what we've got here? Okay, so in this case, my a constant here would just be 1, wouldn't it? Because 1 squared produces 1, and then the x, of course, variable just gets replaced with y. Okay, so the result will be using this, so it'll be 1 over a, right? So a is 1, so it'll be 1 over 1, which is just 1, so I don't need to write that, tan to the minus 1, and then of course it'll be x over a, so that will be y over 1, okay, which is just y, and that equals to then 1 integrated just becomes x plus then my c. Okay, so I've got tan to the minus 1 of y equals to x plus c. All right, then we'll work out what the constant is. So we say, look, when x is 0, y is equal to 1. Okay, so put that in. So tan to the minus 1 of 1 is equal to 0 plus c. So quite simply, we just need to work out what tan to the minus 1 is to get c. So what's tan to the minus 1 of 1? Now, when you do this in your calculator, remember it's got to be in radian mode. Okay, so I've got it in radian mode there. But if you haven't, just change it. So shift, setup, angle unit, and then radian. Okay, so tan to the minus 1 of 1 equals to quarter pi, right? So pi over 4. Okay, leave it like that. So then we have tan to the minus 1 of y equals to x plus pi over 4. Okay, and then you've got to think that we need to get y equals, well, because it's tan to the minus 1, reverse the process to take it over, of course that just becomes tan. So y will equal to tan all of this. Okay, that's the reverse process of tan to the minus 1. So it becomes y equals tan to bracket of x plus pi over 4.